Hello, welcome to this session, ESSS 2022. Uh, Today, I would like to discuss about safety analysis of battery management system, an integrated and model-based approach. My name is Madhu Kiran. I am a senior application engineer at Ansys. So, in today's session, we will be talking about how the electric vehicle buyers' requirements are changing so how it was earlier and how it is changing today. Then we will be talking about what is the importance of battery management system, and it's a functional safety analysis of battery management system. What is the traditional approach, and then what is the latest model-based and integrated approach which customers are all adopting. And we'll be also discussing about functional safety analysis of battery management system in accordance with ISO 26262. So, before starting, let me introduce Ansys. Ansys has founded in 1970, and it employs about 500 plus professionals globally. And it started with mechanical solver. In last 2 decades, it has expanded in various areas in embedded software, in physics, in control system development, in engineering analysis, and it has acquired various companies in past decade, which also includes the latest acquisitions like AGI and Phoenix Integration in 2021, and in 2022 it has acquired Motor Design Limited. Today, I will be talking about the battery management systems, and also let's see how the electric vehicle buyer requirements are changing. So, if I discussed about electric vehicle to any prospective buyer, say my friends and all earlier, so what was their requirements? What they used to look in electric vehicle? So the first thing used to start with the range, so which we used to call it as the range excitement and all. So where users used to talk about what is the range of the vehicle, or what is the cost of the vehicle, whether the infrastructure is available for charging, and what is the charging time. So these were some of the requirements from buyers. But if we look in recent incidents which are happening with electric vehicles, so earlier also there was some incidents which happened with electric vehicles, but it was not in news. But today, if we see, we are seeing many electric vehicle accidents which we are seeing in news, in social media, and all. And it has also attracted the Ministry of Defense view in that, where even Nitin Gadkari also has commented on the safety of the electric vehicles. Now, post this, I spoke with many of my friends who are prospective electric vehicle buyers who are planning to buy an electric vehicle. If I asked them about their requirements on electric vehicle, the first thing which came into their mind was the safety. So earlier, of course, the range anxiety, the cost, all this is still there, but on top of that, now safety has become a priority, where every electric buyer now is looking for both passenger safety and also vehicle safety. Because why vehicle safety is, yes, once user invests on the vehicle, and if some damage happens to the vehicle, yes, of course, insurance and all these things are there, but we don't know how much amount will be reimbursed and how much loss the user has to bear. So all this, even the user is also considering his personal safety and also the vehicle safety. So safety has become a very important factor when it comes to the electric vehicle. When we are talking about safety of an electric vehicle, the first important, the idea goes in the direction of a battery, because a battery is the key component in an electric vehicle, which has a capability to explode or to burn in some scenarios. So that's where actually battery plays very important role. And even when we are talking about an electric vehicle, the safety is first looked at the point of battery. Now, it's not just alone the battery. So the main key factor in when it comes to the safety is the battery management system, which is actually managing the battery pack. So because the battery management system, we know that the BMS ensures the operational safety, efficient charging, etc., etc. So that the way BMS is arranged, so that's where actually the safety comes into picture. So BMS plays very important role when it comes to the vehicle safety. When it comes to functional safety analysis, now the key important factor here is the automotive standards. So whenever we are developing any electric vehicle and when we are performing the functional safety analysis of the battery management system, the main important factor which we need to remember is the standards, the ISO 26262 standards, which we all know, which is the latest version of ISO 26262 standards are 2018 version, where we will be in today's session we will see how the functional safety analysis of a battery management system is performed in accordance with ISO 26262 standards. Now, when it comes to the functional safety analysis, earlier the idea was the safety analysis is a process which is performed at the end of the product development cycle, but it is not the case today, where the functional safety analysis need to be started right from the requirement phase, where the functional safety analysis starts right from requirement phase, where importing requirements, that's from there the safety requirement starts and it goes till the end of the product development cycle. Because of this, it has become a necessary that the safety teams need to be deployed at every stage of the development cycle. Earlier, it was like the safety teams used to be there at the end of the development cycle, but today it is not the scenario. The safety developments need to be there right from the starting of the development cycle. When it comes to the functional safety analysis, it is also said that the functional safety analysis is an iterative process. It is not that at the end of the development cycle, we perform a safety analysis and we close the safety analysis. It is not that. So safety analysis is an iterative process where first the safety analysis is performed until we get the desired results, the safety analysis need to be performed. Now, how engineers are performing today the safety analysis? So what is the traditional approach? Now, in this traditional approach, there are various softwares which engineers are using. Let us say that for requirement management, they are using requirement management tools like IBM Doors, JAMA, and for drafting safety concepts, they are using Word document. For defining the architecture models, they are using SCADE Architect, IBM Rhapsody, and various architecture modeling tools. And for performing hazard analysis, FMEA and FMEDA, they are using Excel sheet, and they are using various tools for performing reliability analysis, their fault tree analysis, etc., etc. The disadvantage with this traditional approach is that we need to switch between different tools to perform the safety analysis. So it is not that we might have requirements in we might have safety concepts in Word document, and these safety concepts we need to use in an Excel sheet, and the data which is coming from an Excel sheet need to be exported in some other format. So there are various formats we need to exchange. So the disadvantage with this approach is there is no consistency. And there is no traceability, because all these are point tools, and we cannot establish a traceability between different work products. And whenever it comes to the safety analysis, engineers today are doing a lot of repetitive tasks where multiple work products need to be made as a copy whenever they are working with different tools. The disadvantage with this is if there is any change done in one tool, now it will not reflect in another tool, and it also need to made as a different copy work, different versions and all. With this, engineers today are ending up with creating multiple work products, and they are also ending up with creating multiple versions. So this is creating a lot of confusion when it comes to the functional safety activity. For this, the best way is to go with model-based and integrated approach. Where in this model-based and integrated approach, it is always necessary to have one single tool where we create architecture models, we define safety requirements, safety goals, perform hazard analysis, FMEA, FMECA, FMEDA. So it is like one single tool which helps you to define architecture models, perform safety analysis, and also establishes traceability between these work products. So such kind of workflows are necessary whenever we are performing safety analysis of complex systems like the battery management system. So this will reduce time and also improves efficiency. So today, I would like to take you through one example where we perform the functional safety analysis with model-based and integrated approach. So I would like to take you through one of the workflow. Let me introduce you to the battery management system. So what is the workflow of a battery management system? So where we have the BMS design and validation, system level simulations, functional safety and cyber security, and embedded software development and validation. Where in BMS design phase, we are continuously talking about the BMS design, its implementations, and various scenarios. And when it comes to the system level simulations, we are seeing various scenarios how the BMS is performing, and also functional safety analysis is also going in parallel right from development phase till the implementation. Functional safety analysis is also going in parallel, and finally, it also talks about the controller software development and its implementation. So today we will focus on the functional safety aspect for the battery management system. Uh, Medini is one such tool which helps you to perform the functional safety analysis on model-based and integrated approach. So when it comes to the ISO 26262 workflow, so it actually starts with the safety management. Then we'll be talking about item definition, defining item level functions, vehicle level functions, system level functions. And from there, we'll be going in performing the hazard analysis and risk assessment. And then we'll be talking about the functional safety concept. And from there, we'll go into the technical safety concept, where we'll be talking about the functional safety analysis of both hardware and software level separately. Now, how do we implement this particular workflow for a battery management system? That's what we'll be looking in this slide. In the previous slide, we have seen the functional safety workflow, where actually we started with item definition, then functional safety concept, technical safety concept, and all. So when it comes to the functional safety concept, the first important aspect is creating the architecture models, because architecture models gives a clear picture of the top level view of the system. So it actually starts with item architecture on an item level. In item architecture, we will be actually describing the architecture model as a block diagram. So it's a model based approach. So always representing the architecture models and block diagram is possible. So architecture models will be represented on a block diagram, where when it comes to the battery management system, so we have a BMS ECU, a crash detector, a switch box, cell stack, and there are some sensors which are monitoring the state of charge and state of health and all. So this particular system will be actually represented on an item level, which actually plays a very important role when it comes to the functional safety activity. The next comes is the functional safety architecture. In functional safety architecture, on an item level, we have just represented as a block diagram. But when it comes to the functional safety architecture, we should actually represent what is the functionality of course, the overall functionality we need to represent, and we should also represent the functionalities of each and every block. What does the BMS ECU? What is the functionality of BMS ECU? What is the functionality of the crash sensor? What is the functionality of switch box? What is the functionality of cell stack? The functionalities need to be represented on a functional level. When it comes to the technical safety architecture, we should represent what are all the various hardware components are there in an ECU, what are the various hardware components are there in the crash detector. It is not just an ECU and all, there are other hardware components as well, like there will be power supply modules, there will be a watchdog, there will be CAN transceivers. So there are various other hardwares which are available. So all these hardwares also need to be represented on a technical safety architecture level. Then from there, the next level will be on a software safety architecture. On a software safety architecture, actually the actual functionality of the BMS is running on an ECU. Then we need to actually represent what type of ECU it is, whether it is an AutoSAR implementation, whether it is a non-AutoSAR implementation. All these details also need to be mentioned when it comes to the software safety architecture. Like for example, if we take an AutoSAR implementation, we need to represent what are all the things are there on an application level, on an RTE level, on a basic software, OS, MCAL. So all these layers also need to be represented, and the functional safety analysis also need to be performed accordingly at different stages. Now on the software safety architecture, that actually plays very important role. Now, when it comes to the hardware safety architecture, in hardware safety architecture, we need to represent what are all the various hardware components are there, whether it is an active component or whether it is an IC, what sort of hardware components, all that libraries need to be represented on a hardware safety architecture level. So these architecture models gives very detailed representation right from an item level till the hardware level, and this plays very important role when it comes to the functional safety analysis of a BMS system. Then tools like Medina Analyze will implement SysML modeling approach for to represent this architecture models. But if you have already created an architecture model in any other tools, you can also import them. The next step is to perform the safety analysis. So this is actually where the safety analysis is performed. The first important task will be the Hadoop analysis. Now, in Hadoop analysis, we have defined functionalities of BMS ECU. What is the functionality of a crash sensor? What is the functionality of power supply modules, etc., etc. So there are various components in our item architecture which we are represented, and each and every system has various functionalities. Now, these functionalities consist of various malfunctions. Now, we need to represent these malfunctions in Hadoop analysis. Like there are various templates which are provided by various tools, like which we call it as guide word templates, and there are various templates available. Using these templates, we will be defining functions and its malfunctions. It is nothing but we will be defining a function and we'll be telling in whatever ways this function can fail. So that particular analysis will be performed in the Hadoop analysis, and we'll be also defining various hazards in the system. If a particular function has a malfunction, what hazard it leads to. So all the hazards also need to be defined in this Hadoop analysis. From there, the next step will be is to perform the hazard analysis and risk assessment. Let us assume that there is a battery, there is an overheat, and we need to see in what condition this particular malfunction is occurring, and whether that is severe or in this situation this is occurring. All the scenarios, everything need to be described in the hazard analysis and risk assessment. Of course, we know what are the functions and malfunctions, but we need to define various scenarios where we will be defining severity, exposure, and controllability. So exposure is nothing but talking about various scenarios. So that need to be defined in the HARA templates. So there are various templates available. So in that HARA templates, we need to define them, and finally we need to arrive to the SE levels, which are nothing but the product of severity, exposure, and controllability, where we will be defining if this particular function, if this particular malfunction comes under which ASIL standards, whether it is ASIL A, ASIL B, ASIL C, D, etc. So we'll be defining them in the ASIL determination. The next step will be is to define safety goals and safety requirements. Now, when it comes to safety goals and safety requirements, there are many instances where the safety goals and safety requirements will in some cases these safety goals and requirements will come from the customers, and the safety analysis need to be performed by tier 1 as well. Now, in that case, the safety goals need to be defined and it has to be linked with the ASIL levels. Then from there, we'll be performing the fault tree analysis, where each and every safety goal will be considered and safety goal violation will be taken as a top level effect, and we will arrive to various root cause analysis for violation of these safety goals, which plays very important role. And from there, we'll be performing the next analysis called FMEA, where in FMEA we'll be evaluating various risks and what are also recommended actions. So we'll be calculating the RPN number. We'll be assigning various detection mechanisms and all those things in the FMEA. And the next step is to perform the FMEDA, where we'll be talking about each and every hardware components, its failure modes. Let's say that there is a power supply module or there is a CAN transceiver, and if that particular module fails, then the entire system will not work. So then we will be talking about that particular component, its failure modes, and its top level effects will be analyzing in the FMEDA, where we can also create various libraries where we'll be talking about these components and all. And we can also perform FMEDA for hardware components, or we can also perform FMEDA for a semiconductor IP as well. So this is where actually this plays very important role. Now, whenever we talk about the safety analysis, so there might be some instances where the requirements will be defined by the OEMs, and the safety analysis might be outsourced to a tier 1. Then in that case, the Hadoop analysis, the HARA, defining safety goals and safety requirements, and also assigning the AC levels might be assigned by by the OEMs, and tier ones will be performing the fault tree analysis, FMEA and FMEDA. Now, in that case, the advantage with this model-based and integrated approach is that we can actually enter at any place, any stage in the safety analysis workflow. It is not that we need to do everything from scratch. So if we have the relevant data, then we can enter at any stage in the safety analysis workflow. Actually, the advantage with this approach is, the first important advantage is the traceability. See, what happens is we are performing the FMEA, FMEDA, all these analysis we are performing. Then we are also arriving to various metrics like the PMHF, SPFM, LFM, various metrics are arrived. Now, with this, we can actually say that if there is a component and if it has a failure mode, how this failure mode affects the top level safety goal violation, or let it be the function malfunction, how it is linked to the top level. We can actually establish a traceability because of the integrated approach. So as we are performing all the analysis in one single tool, this helps us with the easy traceability. And to establish this traceability, we don't need to actually create multiple work products, so which is very consistent, and we can perform all this analysis in one single tool, so that we don't need to actually repeat the tasks. And it's a simpler workflow. And if there are any updates in anywhere in the safety analysis workflow, then we can simply update. Let us assume that there is a safety goal modification in the HARA sheet. Then once the safety goal modification is done, then it will affect it in all the areas where that safety goal is linked to, so that we don't need to manually update at every stage. And this will reduce the effort, and also reduces the time. So this is very important feature of using the model based approach. So if we look at some of the use cases where customers are using model based approach to implement their functional safety activity, where not only performing the safety analysis, we can also integrate with other areas of your system. Like, you can integrate with your system engineering tools, you can integrate with your graphical tools, or you can integrate with other physics based platforms and all. So that the whenever we are dealing with complex systems like battery management system, functional safety analysis, so this approach really helps. So you can also see customers who are using this tool for performing the safety analysis. The main idea is that whenever we are dealing with the complex systems like the battery management system, the traditional approaches is not recommended because of its complex nature, and too many iterative approach. So a model-based and integrated approach really helps in this case. And Medini Analyze is one such tool which helps you to perform such kind of integrated safety analysis. I hope this session helped you. Thanks a lot.